Which transformation would not carry a square onto itself? So to answer this question, we have to be aware of the types of symmetries that a square has. So a square has 4 lines of symmetry, right? If I take the square and fold it over those 4 lines that I drew in, then it's going to land on itself. It also has rotational symmetry. What exactly is the angle of rotational symmetry? Well, as it turns out, if you notice here, these, excuse me, the lines of symmetry there intersect at that common point, and those lines of symmetry are going to be spaced 45 degrees apart. Whoops. So let's use a different color there. So this is going to be 45 degrees a piece. So it will have rotational symmetries as long as the rotations are multiples of 45 degrees. So 45n. Now the question here is asking for which transformation would not carry a square onto itself. So let's see, a reflection over one of its diagonals. So its diagonals is definitely one of the lines of reflection. So it will, the square will land on itself. So this is not the answer choice that we want to pick. A 90-degree rotation clockwise about its center. So 90 degree is a multiple of 45. We multiply 45 by 2, we end up with 90. So it will land on itself. That's not it either. A 180-degree rotation about one of its vertices. Again, that is not good, because if we rotate 180 degrees about one of its vertices, no, I'm sorry, it says 180 degrees about one of its vertices. So this will work, because if I take this, let's say if I rotate the square over that vertex there that I'm highlighting in red, 180 degrees would land me over here, right? So this point, 180 degrees would be there, and it would not land on itself. So option 3 would work. Option 4, a reflection over the perpendicular bisector of one side. So a perpendicular bisector is this guy, so that's not it. So the only one that does work is option 3. So again, 180-degree rotation about one of its vertices.